today is the energy, because predominantly a lot of systems are working at 150 psi, where some of the micro-irrigation systems that are putting the water on at the same rate are working at, 5, 10, 15 psi. Well, we'll come on to that later and I'll explain where the cost savings are there. Weather, that's another big considerable issue, because if we get windy weather and you're using your hose reel with the nozzle, then you get uneven application of the water, so that's another waste. But mainly, the main thing you have to consider with the planning and design is the system practical for you, and have you got the people who will be responsible for it. So, another consideration in planning and design elements, the topography. If you've got very undulating ground, then what I saw on Friday was you use damodikers between the rows. This reduces the amount of water that will run down and erode the soil. The water source. This is quite important if you're using micro-irrigation systems, because if you have water that's got iron in, then there's a chance of plugging the irrigation systems. Something that I will touch on a little bit, but if you're putting fertiliser through the irrigation system and the water quality has a high bicarbonate element, then you can get problems with bicarbonates participating out and blocking up the irrigation system. Another thing, is there room to expand your system? Meaning, if you've got 100 acres and you've only got enough water for 50 acres, then do you need to look at expanding your water holding capacity, i.e. reservoirs, etc.? Do you need to change your cropping systems to accommodate what you've got? And the cost. Cost is something that I'll come on to it a bit later, and I'll explain what I mean about that. And also, I'll keep coming back to the thing, practicalities and you. Systems are all about people. So planning and for topography, this is where I was coming from, because I've put 10 metres is 1 bar, so 10 yards is 1 bar, or 15 yards is 15 PSI, is that right? I'm sorry, I've got this in metric. I have changed quite a lot of it into your Canadian dollars. This will make a considerable amount of difference to the pumping system that you put in, because if you're pumping, which here I think they said your highest point was 300 feet from sea level, well, we get places in the UK where we're sort of 100 metres from sea level or from the pumping. So if you can imagine, I've got a pump at the water level, and in pumping 100 metres, it's costing 10 bar or using 10 bar of pressure before I actually get to where I want to be. So if I'm using a hose reel, I've got a 10 bar lift to where the field is, and then I've got to put another booster pump in to take the pressure up to 10 bar. So this is something that, consumes a huge amount of energy and has to be planned. Is the water from mains? When I say mains, I mean municipal water. This is very expensive, but in some parts of the UK we have to use water from the mains. Boreholes, you're on quite a good aquifer here, so I understand, and we'll not touch on that subject too much because I think it's a bit of a hot topic at the minute. What I can't understand though is if your borehole yields more than 50 gallons a minute, is that correct? You can't use irrigation water for potatoes? Is that what my correct understanding?
That is correct, yeah.
I find that difficult to understand why they do that, but that's another thing. Or other water, surface water, rivers, which probably most of your rivers are salt water here. I haven't touched on this in the presentation, and people were quite horrified. But what we've done in the UK in places, we have actually took brackish, saltish water and put it through trickle irrigation for potatoes. Because the brackish water, as you know, if you put it overhead, it will kill the horns, but actually if you put it into the soil, it will actually act as supplementary water for the potatoes. Problem being, in an arid country, you will build up the salts in the soil and destroy the soil, but in a country with a lot of winter rainfall, you wash the salts out generally. And we're a 1 in 6, 1 in 7 rotation. Here you're 1 in 3, but that's just by the way. Correct filtration, that's the other main thing when looking at drip irrigation or micro irrigation. Water availability. Well, water availability. When I was in South Africa doing my Nuffield, a chap told me that only 3% of the surface water on the earth is fresh water, of which a substantial amount is locked up in ice caps, and demand has doubled every 25 years since Roman times and continues to do so. So that's quite a sobering thought. This picture, you can see, this picture here demonstrates the subsurface drip, because there are two types of drip. One is subsurface, where it can be buried from 1 inch, 2 inches, to up to 18 inches, depending on the soil and depending on the humidity where you are. And the other type is this surface drip, which is on the top of the soil. The reason why I'm showing you this, because this type of drip is not quite as efficient as this type of drip, as you'll see. So, where have we come from in the last 30 years? 30 years, yeah. Predominantly in the UK, in the early 70s, all irrigation was done with sprinklers, and the sprinklers were laid out on a 30-yard by 30-yard configuration, and every 4 or 5 hours they were moved. In the mid-70s, the hose reels came in. Probably 95% of conventional potatoes grown in the UK are irrigated with hose reels. Why? Well, this was a revelation in the 70s. It meant you didn't get your wellies full of mud when you were changing the sprinklers going across the rows. And then, as the hose reels came in, more potatoes were irrigated because it was easier to do so. As time and resources became more valuable, we have to operate all our equipment as efficiently as possible. This means getting the correct water pressure at the nozzle of the rain gun, to get the correct droplet size and to get the correct bout width, which obviously can be affected by wind. To do this, we have to understand the main constraints in this area of distance, pipe, pressure and diameter, because we see irrigators coming out with longer pipes, but in actual fact they're smaller machines, because the longer the pipe, the more friction loss. So it all adds cost and it consumes energy. So there are becoming doubts over the efficiency of hose reels, particularly when you look at the crop, if they've been irrigated when it's windy, because of the bout width. There is a move on to booms in the UK, but the problem with booms is perhaps they put the water on a little bit too fast. So, things to consider: longer pipes with the same nozzle are smaller machines because you're using power and friction loss is high. But this is a picture taken only last week in a crop of Morris Piper potatoes just down the road from me. It's on my uncle's crop, and they'll do 20 tonnes to the acre quite easily. Then, what we've done I started in 2004 bringing solid set sprinklers into the UK, and this system has 2 pipes, polyethylene pipes, 63mm pipes. So we have 2 8-metre pipes, so we have a 16-metre by 16-metre grid. We do it on a triangle. This system will put on about 5 mil an hour, so it's actually matching the infiltration rate of the soil very nicely and using the water quite efficiently. One of the big benefits is that putting the water on slowly and frequently and slowly, it goes through the profile, and it's not like putting an inch on at once where you saturate the soil and then you have to wait 24 hours for the drainage. So, next thing, systems, soil types and crop. I've covered this briefly, but one of the main messages today is to match the infiltration rate of the soil with the application rate of your irrigation systems. To do this soil profile, it's very important to get the infiltration rate through the soil profile, because as we all know, the depth of rooting for the potatoes is quite deep, and if you just put the water on the top, you need to get the water to depth, then it increases the holding capacity. Crop needs and market specification. In the UK, probably the biggest market share is for processing, followed by the supermarkets, which is the table potatoes. And we use two types of irrigation really, because if we're looking for the table potatoes, it's the quality and the skin finish and the uniformity of tubers we're looking for. I know that's also required for the processing potatoes. However, the cost or the price paid for processing potatoes over table potatoes has been significant over the years, probably 50 to 100% difference in price. So, here's for some science. Before I go on, I'll tell you a few facts and then we'll go on to the other bit where I want to look at the soil and how we do it. Predominantly in the UK, the hose reel has been putting on about 21 millimetres per hour per acre, and that's with a 72 metre boom, and that's on a 12-hour pole, 400 metres, and that's what people do because that makes it efficient use of the investment in the hose reel and boom. Solid set sprinklers on a 16 metre by 16 metre spacing, 5 millimetres per hour, that's over per acre. Drip tape on one tape on every 36-inch row, spaced at 20 centimetre emitters at 1.25 litres per metre. It's putting on 1.4 millimetres per hour. So this really does match the infiltration rate of the soil very nicely because you can put the water on for several hours and it's nicely wetting the soil without saturating it. Drip tape that we're using in the UK for processing potatoes, we're doing on 36-inch rows, but we're pushing the rows into 30-inch, making it into a semi-bed, so in the middle of the two rows we're lifting the middle ridging body and putting one tape down the middle and burying it about an inch deep. This is giving about 3/4 of a millimetre, 70 mils per hour, 0.7. And then the surface drip, which I showed you in the picture, this is something that's come from Israel and different countries. It's quite expensive, but it goes on the top of the soil, and as we'll come on to later, I'll show you the differences. But this puts on about 1.4 millimetres an hour. So the point here really is, most soils can't take much more than 15 millimetres an hour. Predominantly heavy soils take 5 millimetres an hour. So you really have got to look at the infiltration rates and match it with the application rate. So, here comes the science. You all know the soil classification pyramid, and the reason why I put this on, because here we have the clay. So as we get further up the clay, there's better water holding capacity, so little and often, and as we get to the sandy fraction, then it generally needs more water more frequently because it hasn't got the holding capacity. So on this slide here, this just demonstrates that if you irrigate the sand and fill the profile up, it soon loses the water. So as I said before, matching infiltration rate with soil type and crop demand is quite important. With the silt here, we see that that's a bit better water holding capacity, and the clay has a very good water holding capacity. But not many people want to grow potatoes on clay because it poses a challenge at harvest and also at planting, and predominantly it's a colder soil. So when I say we have the soil, I'll take the top one in detail. This is the soil particle. This is the water that's never available to the plant. This is the part in the profile that's available to the plant. And if we get into this situation here, we've got too much water in saturation. So putting water on little and often and keeping in this band produces optimum growth for the crop, and it maintains the soil structure, and the soil is available for the water is available for the crop. just to demonstrate it again, you know, we've got field capacity. You're familiar with field capacity? Yeah, and permanent wilting point. Yeah, so with micro-irrigation, or with any irrigation, this is the band you need to keep in. And depending on the soil type, it will depend how frequently and how much water you put on. Is everybody with me? Nobody's fallen asleep yet? Because I know it's quite a challenging one, this one. This is another thing, and I can't emphasise enough how not to put the water on. This one demonstrates putting the water on very fast. So when you saturate the soil, you take all the air out, it becomes anaerobic and crop growth stops. If you put the water on nice and slowly, then you keep the air and the soil in balance and you get maximum crop growth. Also, you maintain the soil structure, because as we all know, you have to have good soil structure so it has good water holding capacity and also good root growth. Coming back to what I said about the surface and subsurface irrigation, this here demonstrates the surface irrigation. So that's a drip pipe on top of the soil, and this shows the spreading pattern after 10 hours after the irrigation had stopped. This is where buried drip is, subsurface drip below the surface, and the same irrigation on both slides. And this is the picture in the soil after 10 hours. It's actually about 45% larger wetting pattern. So where you will have this soil saturated to a degree, you have this soil that is nicely wetted up. So you're matching infiltration rate. Don't know if you get pictures like this here. This is where it's been irrigated and the soil's quite hydrophobic. It'll be a silty type soil, and what's happened there is the soil's capped, and then we'll put the irrigation on, and the irrigation has just gone straight into the wheelings. You knock the cap off and the soil's dry underneath. So not everything's what it looks like from the surface. You know, another thing for putting water on too fast, if this was irrigated probably 3 times, at a third of the amount of water each time, the water would have gone into the soil profile, because the secret is to wet this soil up and then put the water on again, and it will percolate into the soil. This is a bit of a cost study that we did last year. So basically what we've got here, we've got a 50-acre block of potatoes, half an inch of water every week, over 4 days. That's what we wanted to achieve. We wanted to achieve half an inch over that crop over 4 days, 50 acre. This is with trickle irrigation, twin tapes. If you can see, the cost of the infrastructure is based over 10 years. This would be the tape, the pipe, the valves, the filter, and the labour to lay and retrieve would work out about $600. Oh, I've got a hectare there. It should be acre. Sorry about that. That's one I haven't changed. And the time to apply half an inch of water to the whole 50 acres using twin drip tape irrigation will take you 45 hours. But the interesting figure is, and we'll come on to it a bit later, the total energy used to pump that water was only 59 kilowatt hours. Are you familiar with kilowatt hours? Yes. Yeah? I'll come on to that a bit later on as well. So this was a comparison. We've got trickle with 2 tapes. This is solid set sprinklers that you saw in the picture earlier on a 16 by 16, applying half an inch of water every 4 days. This was for scab control. Cost $500 an acre over 10 years for the infrastructure, labour, management, etc. Interestingly, if we went back to the other slide, we're using 1 gallon of fuel on the diesel pump an hour to pump the water. On this one, on the sprinklers, we're using 1.5 gallons. The main reason being the drip tape was using between 0.6 and 0.8 bar, which is, what's that? It's about 10 psi. And this system would be using 30-35 psi. So immediately you can see there's a difference in the total fuel used, which is reflected on the kilowatt hours. So on the tape you've got 59 kilowatt hours, and on the sprinklers you've got 262 kilowatt hours. So, you know, nearly a fourfold increase on energy just in a small increase in pressure. But what is significant is we come on to the hose reel with a boom. Cost $520 an acre, and that was based on a 110 mil boom, 400 metres long, 72 metre Briggs boom, labour and management. So the cost over 10 years for each of the systems is very similar. However, if you look at the time to apply the water, you're looking at nearly double the time, and this was 10 poles, which on demand would have to be very good, and it would have to have a very regular shaped field to actually achieve that. We'll see again, working at 150 psi, using 5 gallons an hour, but look at the staggering energy cost, 1,041 kilowatt hours to do that. That's quite significant. And we look at the water, and the water is important, but also the cost of pumping the water is probably more important than actually the water and the carbon footprint. So, just coming back to where I got my kilowatt hours from. This is a universal formula. Water energy kilowatt hours equals flow in meters cubed times pressure in meters head divided by 367. And all the figures that I've used to calculate the costs are worked out on this formula. This one also demonstrates that if you got the irrigator a mile from the farm and you are using 50 cube an hour, so sorry, I can't calculate it off the top of my head, but anyway, 50 cube an hour, standard 110 irrigator. If you were pumping a mile through 4 inches of pipe, you'd use 17 kilowatt hours an hour, and that would be day in, day out pumping. If you increase the pipe size, which would be a little more cost, but you will be using nearly 2 kilowatt hours less per hour. So your payback on the pipe on a mile will be about 18 months, 2 years pumping, which is quite significant. And we're using less energy, less friction loss, less power. So it's more profitable to use larger pipe. And this comes back to the planning issue. Make sure things are big enough. So, just to summarise the energy use, I don't know if this is the exact cost here. I've just done a direct comparison between $10 and $14, 0.1 and 0.14 Canadian dollars a kilowatt hour. Diesel costs 0.3. Well, it costs, you use 0.3 to 0.5 litres for a kilowatt hour, and I've done the cost of 0.65 to 0.75 dollars. I'm not quite sure what it is, but this is what it costs per acre inch in energy. So the rain gun at 10 bar, 68 kilowatts hours. Sprinklers, 27. The multi-season drip, which you saw, the surface drip, which is multi-year, the same as the sprinklers. And then if you look at the tape, because it's using such a low pressure, we've got 5.5 kilowatts. And this is what makes the tape system stack up financially, because of the reduction in power required. So, I'm probably ahead of time, but I would like quite a lot of questions. So, my most important message is to match soil infiltration rate with application rate, because if you don't, you will destroy the soil structure, you will get runoff, you will get contamination of water courses. You know, as we see here, you've got to avoid runoff and excessive drainage, because you're leaching nutrients, you're wasting water, and you're destroying the soil. So, have the right system, set up perfecting, delivering correctly, resources efficient, returning profits, because at the end of the day it's all about making profit, and not just financially, but conserving the environment. And so if you get the watering correct and you don't get any waste, then you're naturally protecting the environment. And that's where we all need to be, because we're looking at, here you're looking at bringing legislation in for abstraction water. We're looking at, as I told you yesterday, quite a muddle of renewing the licences, so we have to get everything right. And the final slide, which somebody brought up to me this yesterday, and I'll not read it, I'll let you read it, but it sort of sums water up in a short few words. Thank you. I think that's, Adam Smith sums that up quite well, and I suggest the water is for nothing, particularly in the Northern Hemisphere. So any questions?